How you doing, gang? This is Frankentrain Labs. I don't have any real action stuff, but I did have some successes. I thought I'd share them with you over the last 2 days. One thing I did was I had contacted the people that make the filament that I'm using, which is the PETG, which is a very strong, high temp, resistant, and all that. It's really nice. But I had dialed in 40 millimeters per second, so this part takes about an hour to print, and because it's so slow. And I wrote and I said, well, I'm printing a 50 millimeters per second. Can I go to 150? And they said yes, but you have to change your temperature. If you change your temperature, you can go up to 150. And I go, oh. So I changed the temperature and I went up to 150, and I printed this one and this one in 25 minutes versus an hour for just this one part. So I've cut my print time almost to a third of what it was. See, this one took longer, and this one took less time. So that's, and you can't tell the difference. They're identical. So that's working. So I learned something there. I can cut my print time down by a lot, and that's a big help for me. The other thing was I was rooting around. I'm having all kinds of issues with this stupid board. I keep building them and messing them up, and then making errors and all whatnot. And I was having trouble. So I decided I really need to get this thing figured out, nailed down, and build the board that will go the distance. So I kind of had to go back to basics, and I did a design. This is not a complicated product, okay? You have a effective bridge. You have AC coming in and DC coming out. In this case, it's not really AC, but it's DC one time and DC another time. And what you want out is positive one time and positive here the other time. And what you want is DC positive always out at one point. So we're using the rectifier function, using diodes as a bridge, and we're creating that capability. When this side is positive, it's allowed to flow out. If this side is positive, it's allowed to flow out. Okay, it comes in over here and goes out that way. So always positive on this pin, which we need because of the chip that we're using. It's not a 122. I wrote that by mistake. It's a 7805, and we need pin 1 to be positive and pin 2 to be negative, and then pin 3 is a positive out, and the negative flows out with pin 3. So that has to be in play, and so I had to document that and make sure I had that in my head. The other thing I wanted to make sure I knew was, with these components, I put them in the breadboard. I wanted to verify what I was getting out in AC. Was I going to get enough voltage to trigger that relay? So I marked up my transformer, so I knew exactly where 50, 60, and 70 were. And I created an AC output map table, and then I converted that to DC. So I read the DC coming out in that table, and then I ran it into that chip, and I ran what's coming out of that chip, and I got that out, and it all looks okay enough. I thought it'd be 5, but it's not. It's a little less. Then I did a test. I put the wires onto the thing. I got the 8 volts, and the first test, it didn't turn on until 2.2, and then I found I had something in error, and I rewired it, so I got a T2, test number 2, and it fired as soon as I got to 10 miles an hour. The relay fires, and we're off of idle, and we're onto the Puff and Chuff cycle of the Puff and Chuff board over here. We switched this relay, so instead of a constant flow of smoke, we now have the intermittent pulsing of smoke based on the cam. So that worked out, and I felt, okay, now we're ready to go. So then I went ahead and got my parts, tried to think through the breadboard design. How do I want to do it? And I did a couple. I built one I built one that didn't work. Okay, I don't know what's going on. It just didn't work. I had another one that was working, but it started to smoke, and I said, okay, I'm going to start from scratch again, and we're going to figure this out. So that's what I did, and I came up with a design that is much simpler, easier to build, and easier to map in. So I've got the diode cluster, or whatever you want to call that, still here as in the original design there, but I've made them into a box shape, and the corners are all connected. So there's just a blob at the corners, and you can see that's what I did. I blobbed it at the corners. Then I have my chip down here, 3 pins, and then I put in connecting pins up here so that I can socket this thing in and have a real nice plug and unplug when we do the assembly process and everything else. So then I did my routing, which I'm in the middle of doing now, and I'm out of time, so I'll have to finish this tomorrow. But I feel very, very comfortable with the routing. I'm going to be bringing over some wires. I'll be adding some insulation to a few wires before I solder them up. But it's going to be a pin-to-pin kind of a thing. It's not going to be this globby, everybody's running around blobbed up. It's going to be pretty neat, I think, and it's going to be a little bit more effective. So that's how it's going to work. How it's going to fit is I've decided, I've checked the fit, and the firebox actually has space there. It has space from about, this line up. It's open. The smoke, the motor brushes stick back in here, down in this area, down low, not up high. So this up high is open. So this board is going to fit in this cavity right there. It's just going to fit in there. The components will be on the back side. The wiring will be on the back side, and the socket is going to stick out about here. And I'm going to use this 4-pin socket for the Puff and Chuff, and then I'm just going to have a 2-pin socket for the firebox lighting. They're just going to come up here and plug in. And I may add, at the same time, I may be able to put in a dome light, like up in this area, and have a light shining out into the cab. So I could have a cab light and a firebox light off this board, because I got 5 volts. If the motor's on, we got 5 volts. So that's what I thought, hey, why not just use motor on 5 volts and run those, because they're very low energy. They won't hurt anything, I don't think. I'll test them before I put them in permanently. But at any rate, that's what I got done today. And in the meantime, the Washington team won another game. And that was marvelous to have that happen as well. So I've learned something with my printer, and I've refined this. Finally, I've refined it. I used all my tools. I used all my massive education, just like zero. Breadboard, schematics, tested, getting the detail readouts, knowing what's good and not. Now I'm building my board so I can actually use it with a connector, which is kind of neat. So I wanted to plug it in. Oh yeah, here's the other. There was the original one. This is what I started with. It was not too bad, but it was just too damn thick. Wow, I should see that. Look at that. If I put those pins in the other way, I could have used that. Just stuck it right in there and had the pins stick out. That's pretty interesting. At any rate, I did add the capacitor on this one. Wherever it is, over here. Here's the one that I used with it. It did work. Capacitor did work. Oh, I don't have it on here. Ooh, now what? I may have to put it on the back side. Ugh. That's all right. There's room. There should be room in the middle. Okay, don't worry about it. Good thing I caught that. Yes, the capacitor does smooth out. It saves the relay from getting a lot of buzz from over voltage and, and stuff like that. And that worked. Oh, and I wanted to use, I used one of my LEDs to test, where's that circuit? And I used this like a probe. Where's the circuit? So I could trace the circuit. So these doggone little lights are going to be handy for us as we get going. But this is the last of the Mohegans of fitting a board into the system, and that way I can get this harness down to just about like that. You plug it in, boom. During assembly, you plug it in. That's it. That ought to be real nice. Everything else is coming together. The tender is virtually done. I may want to think about that. May want a bigger speaker. So no, it's just, I'm nervous it's not going to be very loud when you've got this thing out on the track running around, but we'll see. I rewrapped the smoke. I took it out and I wrapped it around the heater one time, and then tied a loose knot, and then packed it back in. I had these holes were getting warm and losing their thread, so I pressed in 4x40 threaded inserts, and so that's now really solid and secure. So I'm going to have to change these parts now to do those. Anything I'm going to do here that's a fix, I'm going to make it so on the others before they go out too. So this one may have a few cuts and jumps, but the others will be more done right the first time. Sorry, Rodney. we'll make it up to you. And I guess that's what I got. That's where I'm at. I really didn't do much of anything else. This was pretty much. Yesterday wasn't a great day. I don't know what was wrong. Both of us were just a little tuckered out from something. Time change. I don't know what. At any rate, we're okay now, and we're in the final stretch. I seriously mean that. Oh, I do have to do some fitting on this a little bit more. Make sure that I have the clearance for the wheel. I put the wheel on with this, and it wouldn't clear. So I've got problems. Okay, I've got to work this out. It's the design fits and all, but I don't have the clearance for that truck, and I really need that trailing truck. Got to have the trailing truck. There's no sense having it without trailing truck. So I'm going to have to come up with a mechanism that gives me that. I'm not sure what it's going to be, but I'll have to rework this somewhat. I already ground it out a bunch, and I got to do something to this side or push it up. I don't know. We'll see. We'll make it. I'm not nervous about anything. I really am. I'm not. I'm just nervous that it's November 3rd already. God. I wanted this out of here so I could be, doing other stuff. But it's a labor of love. I hope you appreciate that. I'm not doing this and torturing myself. I'm doing this because I really, really enjoy building these engines. I just love it. I wish I could build like 6 a year instead of trying to build 3 at once. Is probably my eyeballs are bigger than my stomach, so to speak. All right, I'll let it go. It's after time. I got to get later. That's what we got. I just wanted you to know. I wasn't smoking and joking or nothing. All right.